Next, we're going to hear about a climate modeling consumer report.
Good morning. My name is Mark Franklin. Thanks for taking pictures, Nick. So our group, so this is Julian Tung, Sarah Lytle, sorry, Nick Arachi, and Daniel Mirovich. So we were tasked with working with the World Wildlife Fund, and I'll elaborate on them in just a moment, to basically come up with a climate model tool assessment. So let's go with WWF first. So World Wildlife Fund, you've probably heard of them. They are an international non-governmental organization founded in 1961, working in the field of wilderness preservation and the reduction of human impact on the environment. They have several million members spread through globally, and we were working with their headquarters in Washington, D.C. We never had a chance to meet with them directly in person, but we did have pretty regular Skype calls with them. They were very responsive via email. It was actually fairly easy to work with them once we figured out what the project goals were, which I think everyone seems to have struggled in the first couple weeks to nail down with their clients what exactly it was they wanted, but we got there. So the assignment was to investigate and compile a consumer report of all web-based climate modeling tools in order to assist WWF's international sustainable planning efforts. The ideal tool for WWF and its partners would allow internet-connected researchers in the field to easily carry out climate model projections for specific locations at specific periods in the past or future. So Sarah, you want to elaborate on that?
As we all seem to come up with it took a few weeks to get there, but eventually they gave us the idea of, taking the Serengeti National Park and simply using that and putting this into different climate tools to see if we could find the projections for the Serengeti National Park in terms of specific times, specific locations, both past and present. And this basically gave us a lot of problems because almost none of these models you can choose a specific location. So in the end, we definitely had to modify a good bit in terms of finding the right tool, which kind of, as you'll see, was kind of none of them. And so this sort of presented a good example of the big issue with all of these models across the board. So, yes, would you want to cover that one?
So as Sarah alluded to, the tool that WWF were looking for, the Holy Grail tool, doesn't exist, and that's a big issue because the tools that they've been using previously were either ineffective, out of date, or just had no ability to download data that could be used in a research way. So from here, the tools often lacked basic functionality. So again, it was a process of trying to find a tool that was global, trying to find a tool that could download data that could be usable in the field. Low barriers to entry, being it's free, it's open source, it's online, and I think we allowed a sign-in or an account, but other than that, if there's any money that needed to be paid, it was a veto. And then the last thing was we had issues with a tool that did everything to a broad enough spectrum, but also was able to be accurate enough at the same time.
So when we were initially going through the project, they revealed to us that we were actually trying to settle a bet internally at WWF as to whether or not this tool existed. And the exercise actually proved to be incredibly valuable because it turns out that such a tool does not exist. The one that came as close as possible was Climate Wizard. Unfortunately, while Climate Wizard is actually an incredible tool that allows you to do a lot. You can upload shape files, you can really get very specific geolocations, get very good projections, ostensibly, for all of these locations. The only issue is that we discovered it has been effectively abandoned by the developers. So the back end sort of server support and everything else is no longer online. So while you can log in and initially start to manipulate and get to a certain point, once you try and download that data, which should be in a manipulable file, like you can either download it for use in GIS or you can download it for use in Excel, you actually don't have the ability to download any of that data because the server is no longer online. Which was a shame because this one came really, really close. This is the one that WWF believed would be the tool that sort of checked all those boxes. We've actually reached out to the institutions that were supporting Climate Wizard, but have not received any word back. So it does seem to be dead in the water. Do you want to talk about C-Roads at all?
Yeah, I can. So C-Roads, it's something that actually I've been introduced to in some of my SUSDev classes as well. But basically, what's interesting about this model is it's not a map-based model, so you can't necessarily select an area, but what you can do is test the different CO2 emissions. That was part of what WWF wanted us to do, and test different variables, as you see temperature, sea level emissions, land use, and population. And you come up with graphs and charts, but not necessarily the sort of map-based data that WWF wanted. So while this is a good tool for simple climate policy tests and lower-level classroom exercises, it unfortunately cannot fulfill any of WWF's needs, and this was sort of a consistent theme around a lot of the tools that they gave us to look at and the ones that we found ourselves.
Sure. So the result, the end deliverable that we ended up getting to WWF was a comprehensive report detailing the tribulations of all of the tools that we looked at. It was a difficult process because we had a list of, I think, 17 tools to start with that WWF gave us, and then we added a few more that we found on our own. And once we whittled it down, we ended up with 8, I believe, in the final report that were worth talking about. And the purpose of this report really is to justify funding for the creation of a tool that WWF is looking for. And from what we found throughout our research of these tools, we ended up making a tool comparison matrix, which based off multiple parameters that we were looking for, but we'll discuss in a sec.
So yeah, we ended up with this rather large matrix. And yeah, these were sort of the short list of tools that checked as many boxes as possible. This allows WWF to do a couple different things. One, it provides them a sort of single look page at, hey, look, what we're looking to do does not exist, and here's why. It also, in the meantime, allows them to continue to use tools that are available for very specific things. So it's almost like a cheat sheet that says, if I need to find out this, if I need to find out soil moisture for a specific area, I can look through this real quickly and tell me what tool that currently exists will allow me to do that. So it is a little bit of a stopgap cheat sheet, but its primary purpose is for them to go out and advocate for funding and for the existence of a sort of open source, web-based climate model assessment tool that can be used globally to a high degree of accuracy in very specific geolocations. Depending upon what biome you're operating in, they may be looking at different effects from sea level rise. It is really kind of the holy grail of tools. We're pretty sure something like this exists or things similar to this exist at institutional levels. It's just having access to it. Lowering the bar for access is really what WWF is trying to advocate for, because a lot of their field operatives, they may have an internet connection, but that's really pretty much it. They may not actually have skills beyond that. Like one of the tools we looked at, right, required you to know Java to be able to use it. Maybe not a huge barrier operating in New York, but can be a really big barrier depending upon where you are in the world. So yeah. And yeah.
Thank you. Any questions?
Yes, thank you.
Yeah, thanks. I hope you got some proceeds from the bet, because somebody won. My question to you is, do you think that such a tool should exist? And if it did, how should it represent the uncertainties that we all know are present in climate models, particularly if, say, a manager in Serengeti would be using it to make a particular decision? You want that person to really understand the uncertainties.
Yeah, I think so. Yeah, there's a danger in the sense of if you have something like this and it's wrong or not entirely accurate or right, is not adequately accounting for uncertainty, you could be making really significant policy decisions not being fully informed. I got the sense, at least from the client, that wasn't really the purpose of this. That they weren't trying to go to, let's say, national level stakeholders with this kind of tool. It was more for like a local person who has, a farm and is trying to figure out in general, is my area going to be getting drier or wetter? How many hot days can I plan for roughly? Should it exist? I don't know. I think it should exist. Why the hell not? But yeah, I mean, if it's wrong, I mean, but yes, you're right. If it's wrong, yeah. But some of the spots, with uncertainty, it can be, it's going to be a super drought or it's going to be a flood. Like, so you have to plan really for both, right, and for all contingencies. And I think, the ideal tool would certainly make users aware that there is a high level of uncertainty for many of these things. Yeah.
And I can add one more point to that too. A lot of what WWF wanted was sort of looking at the IPCC and rasterizing the sort of future projections. So not necessarily that it had to be the most correct or even the highest resolution, but just sort of a general overview of the big variables for temperature, precipitation, humidity, hot days, cold days. So it didn't have to be super high resolution, super accurate, but just sort of a general, around the equator, is it going to get warmer, sort of that idea.
So Ruth beat me to the punch. I mean, as somebody who studies a lot about the uncertainties in climate models, this is kind of terrifying. On the subject of uncertainty, was there a sense with WWF about how they might represent that uncertainty? So, all of the top level things like one model is never sufficient. How could a tool like this be used to analyze what the collection of models say, for instance, or how is resolution represented? You've talked about this from a user's perspective of, I live in this location, what's this going to be like? Well, rarely is the spatial resolution of the model sufficient for answering that question. And also it's variable dependent, where we might feel better about what models tell us with regard to temperature than they do precipitation. And there's also well-known locations around the world where the models are doing horribly relative to observations. East Africa is a great example of a place that's been drying over the last several decades, and all the models say it's supposed to be getting wetter. So while I'm not sure it can be achieved, I think my answer to Ruth's question is probably not. It probably shouldn't exist without some structure for helping to translate the results and uncertainties. But did you guys talk about how you might represent the uncertainties in a sufficient way within the tool?
Yeah. So in terms of representable data, one of the things that we looked at was how the data that we download is manipulable and what it tells us and how easy it is to read. And that was one of the concerns of WWF. They figured that a lot of the times that if you download data, if it's not something that of a good enough resolution, you're not going to be confident in your assessment of, say, the Serengeti, for example. So it was. I think that is another stage of this project that is going to be much further down the line. The initial ask of our project right now was to show that this tool doesn't exist and perhaps get some people with money to try to think about it. So.
Yeah, I mean, we're being filmed, so we could talk offline. But yeah, I mean, like all good nonprofits, they've got to raise profits. So yeah, I think a lot of this is advocacy, right? And where they go with it, I don't know. They don't know, but yeah.
I was just going to say, it's actually a very rather old quest because the country was founded on Ben Franklin's Poor Richard's Almanac, and he published it for 20 years, and the farmers were really glad to just have an approximate reading of sunrise, sunset, nightfall, tides and so on. And it's sort of like, I guess they just assumed it's going to be uncertain.
Yeah.
But it was something to put on the mantle.
And my mom still buys it, so yeah.
I have a question just about if you could go over just some of the criteria. You mentioned soil, moisture, presumably temperature. What are some of the others?
So it's going to be hard to read, but gosh, all sorts of, vapor pressure, average low temperature, average high temperature, hottest temperature, coldest temperature, number of rainy days, number of dry days, things like the general resolution of the maps, if they were map-based, general resolution of the data. Could it be downloadable as either image files, or is it downloadable as actual data files that are manipulable? What else? Oh, multiple emission scenarios. That was a big one. We wanted to look at how many different scenarios there were. It was one of those exercises that sort of prima facie, we were like, how is this useful for us, or how is this putting our skills to use? But as we work through it, really the skills that we learned in the program were absolutely directly applicable, because we were able to understand what different emission scenarios mean, like the level of uncertainty and things like that. So we incorporated a lot of our own knowledge into what we know that these things should be looking at, or at least like we have an understanding of what they should be showing. And if they're not showing it, then we know that that's a problem. But yeah, we ended up with quite a few variables.
Just one more thing. On top of that, one of the aspects we looked at through meeting with a WWF colleague in New York, she was asking for seasonality, so whether it be rainy season, dry season, or just pure summer, autumn, spring, winter. So it depended on what the client would want, and that's another aspect of this tool that is probably going to be in the distant future, where it can iterate between each type of seasonality. So.
Yeah, I just want to make a comment about the question, should these exist, should the ideal tool exist? I just want to rephrase the question. These tools do exist in the sense that they are online. So in a sense, this is the title of your talk. This is sort of an assessment of what's available out there. And so in that sense, it's really almost an expose of what's claimed to be tools for this purpose, and it's extremely valuable, I think, in that sense. And also, when I was watching this, I was just running through my mind the amount of funding that probably went into developing these websites was enormous. And so you guys are shedding light on an important area that needs further work, and with all the caveats that are being raised here.
Yeah, I think the big takeaway is don't use any of these. Yeah.
Well, I will say, just to give one credit, the second from the top, the PrEP model, it uses the NASA Next data, and the first 5 columns of this matrix are essentially the most important. These are the columns of people can't use them if not all 5 are yeses, and PrEP was the only one that did have all yeses to web-based, open source, downloadable data, multiple emission scenarios, and localized information. So I will give PrEP a little shout out right now to say that that this was actually a fairly decent tool, but unfortunately it's still very new, and a lot of the data isn't in packages that are very usable to a general population right now. So I think that this one has the most potential out of all of them. A lot of them, for example, the EDGCM required a very extensive download that we actually in the end could never get to download all the way. So that unfortunately we had to use the metadata to research that one. But the PrEP data set actually, it was very interesting because you could look at individual temperatures, they could visualize it, but it wouldn't necessarily tell you that it was it was the future. What you could do was download the data and be able to use it by yourself. So this might be something very useful for those who are in climate science in the WWF, maybe not the most useful tool for someone who doesn't understand the inner workings of climate science, the emission scenarios. So if I were to give one the honorary prize for best, I would say it would be the NASA Next Prep data tool.
Seems like maybe some of the take-home messages are, making sure there's strong characterization of the uncertainties associated with the products. And then another thing I think that's, very challenging probably for a student group to do, but a critical message, for longer-term engagement is sometimes pushing back on the client a little bit and saying, well, let's say you could get vapor pressure data at a certain resolution. Can you describe for us a way that it could actually impact a decision or sort of be helpful for anything related to your mission? I think hard at this level to do that, but it's a good example of that kind of push-pull where maybe you can end up posing as many questions to the client as they pose to you.